Welcome to the video lecture series on Chemical Engineering Thermodynamics 2. Myself, Jamin Pandya, Assistant Professor in Chemical Engineering Department of LJIET Institute of Engineering and Technology. So let's continue with the chapter number 1, which is the phase equilibria. So in this lecture, we are going to calculate various numerical based on calculation of mole fraction in liquid phase and calculation of mole fraction in vapor phase using bubble point calculation and dew point calculation of route flow. So let's calculate this numerical. So in this numerical, given that assume the validity of route flow, do the following calculation for system of acetone, which is component 1, acetonitrile, which is component 2, and nitromethane, which is component 3. Given that x1 is equal to 0.30 and x2 is equal to 0.40, T is a 75 degrees Celsius, find y1 and P. And in case 2, given that find out y1 is equal to 0.45, y2 is equal to 0.35, T is equal to 80 degrees Celsius, x1 and P. So let's write for the case 1. For case 1, if we are going to find out the value of y1 and P, first we have to generate Antony equation. As discussed in previous lecture, in some example Antony equations are not given. So similarly, in this statement Antony equation is not given. So we have to remember Antony equation. Antony equation that can be given by ln PIS is equal to A minus B upon C. So various Antony constants are given here for the acetone, acetonitrile and nitromethane. So let's first make equation for these all three systems. So let's first write for ln P1S. For P1S, A is a 14.39.16, so 14.3916 minus component B, which is a 2795, so 2795.82 divided by T, which is a temperature, which is a 75 degrees Celsius. So here write 75 degrees Celsius, component C, which is a 230. So this becomes our 230. So by calculating, we will get value of P1. So value of P1 that becomes 185.85. Similarly, we can make the equation for the acetonitrile, this P1 for the acetone, and for acetonitrile, this equation can be written like this: ln P2S is equal to A for acetonitrile, which is of 14.2724 minus B, which is a 2945.47 divided by 75, which is our temperature, component C, which is a 224. So by taking antilog both side and calculating this whole term, we will get value of P2S, and that becomes 83.20 kilopascal. Here P1 is also becomes in kilopascal. Similarly, can calculate P2, P3S, that's given by 41.98 kilopascal. So this is our P1, this becomes our P2, and this becomes P3. Now using this value of P1, P2 and P3, can find out y1 and P. Here value of x is given, so we have to use bubble point calculation. So for the bubble point calculation for route flow, that can be given by P is equal to summation of xi pi saturated but this is a trinary mixture, so this equation becomes P is equal to x1 P1 saturated plus x2 P2 saturated plus x3 P3 saturated. Value of x1 x2 given. So let's write first P is equal to value of x1, which is a 0.30, value of P1 which find here, which is a 185.85, so 185.85 plus value of x2 which given in statement, which is a 0.40, so let's write here 0.40 multiply by value of P2, which is a 83.20, so 83.20 plus x3. What is x3? We have to find out value of x3. x1 plus x2 plus x3 is equal to 1. Overall mole fraction is a 1, and here 3 components, so can say that x1 plus x2 plus x3 is equal to 1. So if we want to find out x3, then we have to 1 minus x1 minus x2. So value of x1 is a 0.30, so 1 minus 0.30 minus 0.40, so we will get value of x3, and that becomes 0.30. Okay, so x3 becomes 0.30. So here let's write 0.30 multiply by P3, value of P3 which already find 41.98 kilopascal, so 41.98 kilopascal. Now calculating this term, we will get total pressure P. So total pressure P, by calculating this term, we will get 101.629 kilopascal, which becomes our total pressure. Now using Raoult's law, we can find out the value of y1. So what is Raoult's law? Raoult's law that can be given by, for component 1, y1 P is equal to x1 P1 saturated. So making y1 as a subject, this equation becomes x1 P1s upon P. So x1 which is a 0.30 multiplied by P1 which is 185.85 divided by total pressure which already find here, which is a 101.629. So our answer for y1 which becomes 0.54. So this is our answer, y1 is equal to 0.54. So this is our answer 1. In case 1, told that we have to find out y1 and p. So this is our p and this is our y1. There is no need to find out y2 and y3 because that's not all in a statement that we have to find out y2 and y3. So we can just find y1 here. Now let's calculate case B. In case B, told that y1 is equal to 0.45 and y2 is equal to 0.35. So in case B, y1 is equal to 0.45, y2 is equal to 0.35. So y3 becomes 0.20. So y1 plus y2 plus y3 is equal to 1. For y3, we are for y3, 1 minus y1 minus y2. So we will get y3 is equal to 0.3. And in case B, also given temperature which is 80 degrees Celsius, and we have to find out value of x1 and value of pressure. So we have to find out value of x1 and P. So again let's write Antoine equation that represented by ln pi saturated is equal to A minus B upon C. So for component 1, ln P1 saturated is equal to, here temperature is 80 degrees Celsius, where in case 1 temperature is 75 degrees Celsius. So both have different temperature. So we cannot use P1 and P2 for P1, P2 and P3 for case 2. Okay, we have to again calculate P1, P2 and P3. So let's make again equation for P1, P2 and P3 and calculate value of P1, P2 and P3 again. So this equation becomes 14.3916 minus 2795.82 upon T plus 230 for component 1. Similarly, for P2S, this equation becomes 14.2724 minus 2945.47 divided by T temperature plus 224. Similarly, for component 3, this equation becomes 14.2043 minus 2973.64 divided by T plus 209. Okay, so by calculating this term, we will get the value of P1, P2 and P3. For the temperature 80 degrees Celsius, if we are going to measure value of P1, P2 and P3, we will get P1 is equal to 215.47 kilopascal, P2 which becomes 97.842 kilopascal, and P3 which becomes 50.31 kilopascal. So this becomes our P1, P2 and P3. Now calculate the value of P. Here in statement given that Y1. So if Y1 is given, we have to use dew point calculation equation that can be given by 1 upon summation of Yi upon Pi saturated. For 3 components, this equation becomes P is equal to 1 upon Y1 P1S plus Y2 P2S plus Y3 P3S. Now in statement value of Y1 and Y2 given, so can easily find out the P. So P is equal to 1 upon value of Y1. Y1 is 0.45. So 0.45 divided by value of P1 which is 251.47. So 251.47. Similarly, value of Y2 is 0.35. Value of P2 is 97.84 plus value of Y3 which is 0.20 divided by value of P3S which given by 50.31. By calculating this sum, we will get value of P which becomes P is equal to 103.67 kilopascal. Now using this value of P in route flow, we will get the value of X1. So applying route flow for component 1, we will get Y1 P is equal to X1 P1 saturated. So making subject of X1, so this equation becomes Y1 P upon P1 S. Putting all the value, we will get value of X1, putting value of Y1 which is 0.45 multiply by total pressure value which is 103.67. So 103.67 divided by value of P1S. Value of P1S is 215.47. So X1 is equal to 0.21. So this becomes our answer number 2 for this case B, and this becomes our answer number 1 for this case B. So this is all about today's lecture. I am completing my lecture here. Thank you.